By now, you should be comfortable with measuring different voltage ranges with your DMM. But if you still have any confusion, please refer back to earlier sections and videos, because in this video we will cover the difference between measuring amperage and voltage in a simple circuit. Foremost, it is important to recognize that while there is a relationship between voltage and amperage, as described in Ohm's law, V equals IR, these quantities represent very different aspects of an active circuit. Voltage is always considered as an across quantity, by which we mean that it measures the amount of voltaic potential between 2 points in a circuit. So when we place the test leads on either side of a AA battery, the DMM is saying that there is 1.5 volts of potential electrical energy waiting to go somewhere. And because voltage is measured across or between elements in a circuit, the voltage drop across an element in a circuit can be measured simply by placing the DMM in parallel with the element in the circuit. By contrast, amperage is always considered as a through quantity, because it measures the amount of electrical current flowing through the circuit. This is significant, because to measure current, we cannot simply place our test leads on either side of our battery. Doing so would create a short circuit, because the DMM acts like a single continuous wire when it is set to measure amperage. You never want to create a short circuit, because it will quickly drain your batteries, may cause wires to get dangerously hot or even burn up, and can cause damage to your DMM. Instead, the DMM must be incorporated into your circuit as just another series element. In the same circuit as before, if we now want to measure the current, the circuit must be physically broken and the DMM inserted between the disconnected wires. Remember, when measuring amperage, treat the DMM as you would another jumper cable. Before reconnecting the final cable, the DMM should be set to the correct amperage setting, similar to how we set up the voltage before. In this case, we are now concerned with the DCA section of the dial, which stands for direct current amperage. If we take a closer look at our DMM, we can see that the standard V ohm MA binding post is rated for only a maximum of 200 milliamps. For anything larger than that, we would have to move the connector for the red testing lead up to the 10A option, which can measure a maximum of 10 amps. But for a bulb of this size, it is unlikely that 200 milliamps will be exceeded. If we set the dial to the maximum option of 200 M, and then finish reconnecting the circuit, we can now see how much current is flowing through the circuit. Since we know that Ohm's law states that voltage equals current multiplied by resistance, we should also be able to predict what will happen to the current if we add an additional light bulb to the circuit. Reorganizing Ohm's law, we can see that voltage divided by resistance will be equal to current. Since we know that the voltage is constant for this circuit, and that adding another identical bulb should approximately double the resistance, we would expect the current to decrease with the addition of another bulb. Now that you can safely measure both voltage and amperage with your DMM, you should be prepared for the following laboratory experiment.